Well, hello, my name's Joe Bull. I am an associate professor in the Department of Biology at Oxford and also a fellow at Wadham College. My area of interest is nature and nature conservation science. That's kind of where I spend my day-to-day research activities. But one of the things, I'm not as a historian of science, although I find the history of science really quite interesting. And one thing I often find fascinating about the history of science is the regular reminders that humans receive that we're not the center of existence, we're not the center of everything. And that's something we see crop up every now and again in scientific thought. This idea that humans tend to put themselves on a little bit of a pedestal sometimes, and then every now and again they get reminded by modern science that we are not on a pedestal and we're the same as everything else. So what I'm going to talk about today is a couple of the books that we have in Wadham's fine library collection, which pinpoint a couple of these moments where we've had paradigm shifts, separated by a couple of centuries. First I'm going to talk about Copernicus, and then I'm going to talk about Linnaeus. So to my left here, to the far left, we have a book by Copernicus in the 1500s, in which he proposes that instead of the planets and the sun going around the Earth, which was the prevailing thought at the time, that instead the planets, including the Earth, all went around the sun in what we call a heliostatic model of the solar system. Now, the idea that the Earth goes around the sun at the time, it was not completely novel. It had been proposed as a model by other scientists. In fact, going back to ancient Greece and beyond, others had proposed this as an idea. But really, the reason Copernicus is so interesting, and the model that he proposes in this 1500s text is so interesting, is because it really sparked the point at which this led to such a major paradigm shift that it became accepted as the main model, scientific model for the solar system, that it goes around the sun instead of going around the Earth. It's interesting for a number of reasons. What Copernicus did at the time was that he kind of realized that, there's a couple of things that weren't really very well explained by a geocentric model of the solar system, so an Earth-centric model of the solar system, particularly things like the movement of the planets in the night sky. But up until that point, humans had contorted theories in every way they could to kind of explain, to preserve this idea of the perfection of the movement of the spheres around the Earth, but to also explain what was being observed in the night sky. Copernicus came up with his model, presented in this book, which we can see here, which essentially explained these anomalies, if you like, and instead provided, but it required, this idea that instead of the Earth being the center of everything, and thereby effectively humans being the center of everything, we had the sun as the center with the humans going around it. This became accepted over time. Some people talk about the Copernican revolution, which followed, which really led to things like the scientific revolution and kind of science as we have it today. But one of the things I find really interesting about this is the idea of a principle that emerges. People talk about the Copernican principle that humans don't have a privileged view of the universe. We don't sit at the center and have a position in which we can observe the universe from a privileged position. We have an arbitrary position in the universe and we observe it from there. And so to me, this is not just about the model of the solar system and what that means. It's also quite an important point in human consciousness from a scientific perspective, where we say, indeed, we're not the center of everything. We're just an arbitrary point and we have to observe everything from there. That was the 1500s. We can fast forward a couple of hundred years to the 1700s and look to the second book I have here, which is by Carl Linnaeus. Now, Linnaeus, people may have heard of the name, but he's the father of taxonomy, and we still use the Linnaean system today. He's often talked about as the father of ecology. And really, up until Linnaeus, science didn't really have a way of systematically classifying organisms. Organisms had long lists of names, often descriptive names, but there was no kind of systematic way of saying this belongs here, this belongs here, this belongs here. And what Linnaeus did was develop that system. And it's, to the extent, it was such a robust system that was developed and applied to all the organisms that he was able to do so at the time, obviously leaving some out because we are, talking about the 1700s and there were some things he wasn't aware of. But it's such a robust system that we still use it today. So why have I got Linnaeus here? Well, the reason I have this book, particular by Linnaeus, Systema, Naturae, is because in this tome from the 1700s, Linnaeus for the first time groups humans as part of the classification, the category of primates. So what we have up until now is this idea that you have, certainly in modern science, that you have all organisms belonging to different groups, but humans kind of sit apart, have their own special place. And then Linnaeus comes out and says, actually, when we categorize everything systematically, humans are one of a number of different primates, along with other primates, great apes, etc. So at a stroke, that puts humans as not special compared to other organisms. It places them as one of many other components of the natural world. Now, this did cause some controversy at the time. This classification of humans as one of a number of other aspects of the natural world, but not as something necessarily special, caused a lot of controversy. Ultimately accepted, and today we still talk about humans as one of the species of great apes. But this, again, was not only an interesting classification, an interesting model for the natural world that was a major change in the way that science looked at the world. Again, it also provided quite a major conceptual shift for humans to say, we're not apart, we're not separate to everything else. We are, in fact, one of the many different organisms that make up the natural world, and we're kind of on equal footing in some respects to those. So again, a huge paradigm shift that followed. One thing that's quite interesting to note is that I'm really focusing here on the development of modern science, and actually there are plenty of belief systems that have existed for millennia that have not placed humans as distinct from the natural world. So really, with the Linnaeus paradigm shift, what I'm more interested in is the place of humans in modern science and how science sees us. So again, to summarize, we have the 1500s, we have Copernicus taking the Earth out of the center of the universe and placing the sun at the center of the solar system around which we revolve. In the 1700s, we have Linnaeus saying humans are not distinct and separate and apart, but we're one component of the natural world. So what I'd love to be able to do now is take a tome from the 1900s or the 2000s and talk about how that represents a paradigm shift. But obviously it's quite hard to do that because that's where we are now. So who knows what the paradigm shifts will be? Who knows a couple of 100 years from now, hopefully one of the people that follow me at Wadham College will pull a book out of the library from now and do another version of this video to update it. But I can speculate, I can certainly speculate. And one of the things I would love to talk about is the idea that life might exist elsewhere in the universe outside of the Earth. Now, even though plenty of scientists would say that it's pretty clear there must be life elsewhere, on other planets, elsewhere in the galaxy, elsewhere in the universe, there's still a bit of a prevailing sense of, is that the case? Is life extremely rare? Is life only found on Earth? And so we certainly have no evidence of life anywhere else that we can work with. And I think what will happen probably within our lifetimes, by our lifetimes I'm including my own lifetime in that, certainly within our children's lifetimes, I think we will find the first evidence of life elsewhere, whether that's within the solar system or beyond. It may be that we've already seen it. There have certainly been some papers published in recent years which have proposed to have found traces of potentially organisms elsewhere. But I think we'll have fairly conclusive evidence of life in other parts of the galaxy. So not only will that, I think, take place in the coming years, I think that will also represent a major paradigm shift. Again, at the moment, there's a bit of a sense of organisms on Earth, is life on Earth somehow unique or special and extremely rare? I think the paradigm shift that will follow the discovery of life elsewhere will be rather profound. And I think it will be similarly profound to the conceptual shift we had moving from Earth at the center, moving from humans as a part, and moving to life on Earth as somehow completely unique and rare in the galaxy. So that's what I speculate. We'll see what happens. And as I say, a couple of 100 years from now, I really hope someone else makes a video with the trio of Wadham books, with Copernicus, with Linnaeus, and with whatever gets published in the next few years that finally shows evidence of life elsewhere. So when we're thinking about the potential for life elsewhere, for life outside of the Earth, the temptation is often to think about civilizations, to think about intelligent life, right? And obviously there is an ongoing search for intelligent life. There's plenty of resources aimed at trying to find intelligent life. It would be fascinating if we did find intelligent life, and it would be incredibly, pivotal. It'd be huge if we ever discovered anything like that. That's not what I'm talking about when I talk about finding life elsewhere. It's almost certainly the case that any evidence we found for life elsewhere outside of the Earth would be microorganisms, would be something quite small. It would be no less pivotal, it would be no less fundamental a shift, because it would provide evidence of life beyond the Earth. But the chance of finding intelligent life, I think, is really quite small. And that's partly just because of the scale of space, the time taken to travel between things, for signals to travel between things in space. So I'm not talking about finding intelligent life. What I'm talking about is like evidence of life of some kind. And in terms of how we would find that, now, interestingly, there's, again, ongoing programs to try and find evidence of life within the solar system. I mean, the NASA and ESA and other space agencies currently have programs in place where they have landers on Mars which are taking samples, and they have a sample return mission over the coming years, which was designed to return samples of Martian soil to Earth to test. It may well be we find evidence of life or potentially past life in Martian soil. That would obviously be things like microbes, microorganisms, that kind of stuff. So that's more the kind of thing I'm talking about. There have been efforts to do that before that have been inconclusive. With spacecraft in the latter decades of the 20th century. There are also efforts to detect life through spectral analysis of more distant systems, and there was some fascinating work done in really quite recent years detecting certain compounds in exoplanets, which on Earth are only made by living organisms. They're not made by anything else. So now, that's not conclusive, because it might be there are geological processes that go on other planets, exoplanets, that create those compounds that we don't know about. So it's not necessarily conclusive, but it is, another way we can start to take a route towards detecting life elsewhere. So yeah, so there are ways we can search for life elsewhere, but almost certainly we're talking about microorganisms, we're talking about small things that would be the first kind of evidence I imagine we'd find. I can't imagine us finding evidence of intelligent life any soon, or who knows. One of the things we're slightly hampered by in this search is we don't actually really have we have a working definition, but we don't really have an absolute definition of what an organism is. And that's for another video. I'm not going to go into that in detail now, but it's quite an interesting quirk here, is that it might be that we spot organisms, but we don't have a sufficiently precise definition of what an organism actually is to be able to say for certain whether it is one or not. So that's another interesting aspect of the whole thing. So there's a lot of work we do with the space agencies here at Oxford, led out of the team here at Wadham, but with the Oxford Department of Biology and others. A lot of the work we're doing is mainly around using satellite data to map species on Earth, to map habitats on Earth. We're trying to understand how to improve biodiversity on Earth. We're trying to conserve natural systems on Earth, and we use satellite data to track those efforts and to provide confidence to people to invest in nature conservation, and for many other mechanisms as well. So that's a lot of the work we do with the space agencies at the moment. One of the projects we're involved with is an international collaboration to update the Golden Record, to make the most of increased information storage capacity we have now, and send out a new version of the record on a mission to depart in the 2030s. I'm involved in the biodiversity aspect of that, and what that means is taking a couple of hundred images to represent all life on Earth. Now that's interesting in itself. We're actually using essentially the Linnaean taxonomy to do so, because we use kind of current taxonomic divisions to work out how to assign different groups to different images. What it means is, if you take that approach, you're being as objective as possible in terms of what organisms to include in your kind of portrayal of life on Earth. But the problem with that is it doesn't necessarily reflect human experience of life on Earth, which is quite different. So we're trying to somehow merge the kind of more objective, this is the diversity of organisms on Earth, with the kind of the more human, this is the stuff that's important to humans. For example, if you just use one image for mammals, you have to somehow capture the great diversity of mammals and their interrelationships with humans, as well as humans themselves, in a single image, which somehow seems inappropriate if you then also use one image for comb jellies or some other organism which is obviously incredibly important, but not necessarily as much of a representative of the human experience of life on Earth. Anyway, the point is, yeah, it's a project we have ongoing to kind of update the golden record. Now, again, the idea is that goes out into space, is careening in interstellar space to be found by some kind of intelligence elsewhere, ideally in the future. And obviously, wonderful to imagine that could happen somehow. But really, I think what's so interesting about that exercise is it means we reflect upon ourselves again. And I think, again, it reflects upon our place in existence, our place on Earth, our place in the universe, and where we place ourselves. So I think that's one of the valuable things with that exercise, is that it allows us to, again, reflect on the fact that humans are, we are humans, but are we the center of everything? And how do we see ourselves in the grand scheme of things? So I think it follows in this way the ongoing tradition of, Copernicus, where do we place ourselves in terms of the movement of heavenly bodies? Linnaeus, where do we categorize ourselves within life on Earth? And all the other paradigm shifts that have taken place over centuries of modern science, which inexorably have taken us away from being at the center of existence towards being an important but equal part to everything else. The Copernicus was a gift in the 1600s from Samuel Lee. He was a former bursar at the college. And as for the Linnaeus, that was part of the Richard Warner collection, which was gifted to Wadham in the 1700s. Warner was a former student at Wadham College. And these are just two of the books that make up the remarkable collection that the Wadham Library has. I'm a former physicist, so I'm always extremely excited that we have some original Newton here in the college. We have the Principia Mathematica, absolutely foundational work in the history of modern science, laid the groundwork for how we understand motion, mechanics, all kinds of other things, the Industrial Revolution, until much of the work was superseded later by Einstein and others. But equally, we have some incredible works outside of science as well. And one we often like to show off is the first folio, Shakespeare's first folio, which is the first effort to collect all of Shakespeare's plays posthumously. And we have some fantastic folios there too. So I tend to get extremely excited about the collection in the Wadham Library. I try and find an opportunity to share them when I can, not only in this format, but also with my students. And in fact, this term we had a tutorial built around the Linnaeus, because for our biology students, Linnaeus is a pivotal figure, and one they cite almost every day. Every time they reference a given species, they often mention it's by Linnaeus in the 1700s, the categorization and the description. But these are just two of the monumental works that we're fortunate to have in the Wadham Library, and capture this idea of the train of scientific thought through the centuries. So one of the aspects of having access to these books that I really appreciate is not just what they mean, what they mean for the history of science. And obviously what I've talked about is the fact that both of these books have led to scientific revolutions effectively, major paradigm shifts in the way we see the world. But also just the objects themselves are historical objects. I mean, it's incredible that these things exist and are sitting right here next to me. And if I'm allowed to by the librarian, I can leaf through them, when really they're worthy of museums in their own right. And it's one of the things I enjoy about working actually at Wadham and at Oxford in general, is that you're surrounded by the history of scientific thought wherever you go. You're surrounded by, the paintings on the walls of people who have been at Wadham College before us, people like Christopher Wren, people who are still here now, like Roger Penrose, minds throughout history. The books that we have in the library that are the originals of the works by some of these great thinkers. And one of the reasons I like being surrounded by that is it reminds you that you're the latest in a long line of scientific thinkers. I mean, I will never achieve the heights, I'm sure, of a Copernicus or a Linnaeus, but it's nice to be part of that long chain of scientific thought and research. You're doing your best to kind of contribute towards that chain. But also it makes you, want to up your game in your own research. It makes you want to kind of say, well, I'm doing my best to contribute, and I will, I'm surrounded on all sides by the faces and the writings of all these great thinkers that have gone before me. So I'll do my best to kind of do my own research in a way that's useful and robust. So to me, these books aren't just, they're ideas first and foremost, but they're also inspiration to kind of do the science that I do as well as I can and try and contribute where I can towards progress. What's the word I'm looking for? Lost my words. I know you're going to edit this so I can think about it. Not the assumption. The temptation is the word I'm looking for. Sorry. For some reason it went.